This photo editor allows you to change the weather of any picture you take. So if you were late for the sunrise, or it happened to rain, you can change that with just a series of clicks.
My name is Pierre-Yves Lafont, and I'm a researcher in computer graphics. I'm going to talk about our recent work on image editing. The goal was to make it easy for a casual user to edit a photograph. Making those changes does not really rely on a lot of programming. Rather, it's a data-driven approach. So we gathered over 8,500 images from over 100 webcams, and we annotated each of those images with a number of attributes. So those attributes are some high-level properties like snow or rain. So we used the crowdsourcing. So we asked many workers to annotate our images, and we gathered the annotations from all the workers in order to obtain some reliable attribute labels. So we can use those images and the attribute labels in order to train predictors. And those predictors will then allow us to recognize attributes in new images. So this is for the attribute recognition part, in order to tell how snowy an image is. Now, for the image manipulation, we look at pairs of images from the same scene in our dataset. If you look at local neighborhoods, so groups of pixels that are adjacent to each other, then you will see some consistent changes. So we learn those local transforms from our datasets, and then we apply them to new images. So let's say that we have one input photograph that we would like to edit to make it more snowy. Well, this transformation is not that simple because we cannot just apply a gray layer on the entire image. If you look at an outdoor scene, you can see that when the scene becomes more snowy, the ground might become more white, but the sky might become grayish, and the buildings will become darker because they receive less light. So this means that we have to apply different color changes to different regions of our input image. So we do this by extracting some local features in each region of our input image. So we apply a segmentation to get superpixels, and then in each superpixel we extract features. Those features will allow us to match superpixels to other segments in our database that correspond to the same semantic regions. For example, segments on the ground in the input will get matched to segments in the ground in our database for a similar image. Then, because we have this matching, we can transfer the corresponding transforms that were learned from our annotated database. So we take those transforms and we apply them to the input image. So we developed a search interface in order to search within a photo collection for only images that contain a sunset or that are snowy, for example. And we can do this on arbitrary outdoor images, not just images that have tags or have a specific file names. So this allows us to process large photo collections automatically. So of course, this project has some limitations. It's a data-driven approach, so the quality of the results depends on the size of the database and on how similar to scenes of our database the input image is. For example, if you take an image of a beach and you try to add some snow on it, well, we tried it, it doesn't work. The reason why it doesn't work is that currently we don't have examples of snowy beaches in our database. We cannot create additional texture that did not exist in the input image. So currently, our method cannot go from snow to grass, for example. So if you take an image that was captured during the winter and you try to turn it into summer, well, the snow will become green, but you won't have the nice grassy texture. So we hope that future techniques will be able to take advantage of this data and solve those issues.